here's our lesson on the introduction of percent yield, actual yield, and theoretical yield. So what is theoretical yield? Theoretical yield is what you should get, and it's determined by math. So for us, it's stoichiometry. Actual yield is the lab results, so it's what you produce in the lab. And then percent yield is just actual divided by theoretical times by 100. Percent yield should be an equation that shows up in your background section for the Mass Mole Lab, because we will use percent yield, and we'll also use percent error. So don't get these two mixed up. Percent yield is actual over theoretical times by 100. So we'll actually want percent yield to be a high number, where we want percent error to be a low number. So first let's start with what reaction type number 1 is. So I'm going to do number 1, A and B for you, so you'll have the rest of class while you're waiting for your Mass Mole Lab to heat and cool to be able to finish all of your practice problems on the rest of the sheet. So if we look here, we've got A, B, C, D. So right here I've got two compounds going to two compounds, so I know my reaction type is double displacement. So if I begin this reaction with 20 grams of lithium hydroxide, what is my theoretical yield of lithium chloride? So again, whenever I ask for a theoretical yield of anything, it means what I should get determined by the math that I do. So this is in a perfect world with no percent error, no sources of error, anything like that. What should I get mathematically based on my numbers here? So if I start with 20 grams of lithium hydroxide, okay, I want to go, if I start with 20 grams of lithium hydroxide, I know my unit down here needs to be grams of lithium hydroxide so that those two can cross out. And then I ask myself, can I go from grams of lithium hydroxide to grams of lithium chloride? So no, you never have a gram to gram ratio. So I've got to go through molecity. So I'm going to go from grams of lithium hydroxide to moles of lithium hydroxide. I know anytime I have moles and grams, I have 1 mole, and then I have the molar mass or formula weight of lithium hydroxide, which ends up being 24 grams. So then I ask myself, am I done with my math? If I cross that out, I'm in moles of lithium hydroxide, so I am not done because my question asks me for grams of lithium chloride. So I'm going to continue my T-chart, and I know that moles of lithium hydroxide need to go on the bottom, and then I ask myself, can I go from moles of lithium hydroxide to grams of lithium chloride? And you know you cannot, because you know anytime you go moles to grams, your compounds or elements here have to match. But in this case, now I can use my mole to mole ratio or molecity and be able to go through 2 moles of lithium chloride. So I look at my chemical formula or my map to molecity, and I see that it is a 1-to-1 ratio here. And so then I look and see I'm in moles of lithium chloride. Is that what my question is asking me for? It is not. I need to go to grams of lithium chloride, so I need to extend my T-chart one more time. I know moles of lithium chloride is going to go on the bottom because that's what I need to cross out. And if I go from moles of lithium chloride, now I can ask myself, can I go to grams of lithium chloride? And indeed I can, because anytime you go moles to grams, your compounds or elements here have to match. Anytime you go mole to mole, you've just got to make sure that you've got compounds or elements that are within the chemical formula that you're looking at. So then I look, anytime I have moles and grams, I have 1 mole, and then the molar mass or formula weight of lithium chloride is 42 grams. So when I cross all of those things out, I should get 35 grams of lithium chloride. So that is my theoretical yield. That is how much lithium chloride should be produced. So then in part B, it says I actually produced 6 grams of lithium chloride. So obviously this isn't going to be a great percent yield, but a reminder, actual over theoretical times by 100 is our percent yield equation. You don't need to rewrite that every time, it's just a reminder. So my actual value is 6, so I'm going to put 6 on the top, and my theoretical value is what I calculated in part A, so it's 35, and I have a 17% yield. So this is not the best example to start with, but it's an example nonetheless. We would like that number to be way higher, and you should see that in those future practice problems that you'll do. So again, we want this number to be a higher value, so we kind of have a bad example there. So hopefully in our lab, we should see this be a much higher number in the 90s, hopefully 95, something like that. So again, my percent yield there is 17%. So I would have a very high percent error there. So thank you for coming ready with the notes taken.